In this lecture, I am going to explain about curvature of field. Curvature of field is a monochromatic aberration formed by the lens. Now, the image of an extended plane object due to a single lens is not flat but will be a curved surface. The central portion of the image nearer the axis is not in focus, but the outer regions of the image away from the axis are blurred. This defect is called the curvature of the field. So, curvature of the field is the defect in forming the image of a flat object by a lens. The image of a flat object is not flat, but it is curved. Now, coming to the explanation, curvature of the field arises due to the fact that the focal length of paraxial rays is greater than the focal length of marginal rays. Now, the curvature of the field in the image formed by the convex lens is of two types. First one is this, and the second one is this. In this case, in the first case, here the convex lens forms the real image of the object. This is the real image, and it is inverted. The real image is formed when the object is placed beyond the focus of the convex lens, and this real image is inverted. In this case, the image is curved, which is a defect called curvature of field, and this curvature is similar to the curvature of the convex lens. That means the curves towards the curvature of the lens. And in the second case, this convex lens forms virtual image of the, this is the virtual image of the object, OJ. The convex lens forms the virtual image when the object is placed before the focus length of the focal length of the principal focus of the lens. That means the object distance is less than the focal length of the lens. In this case, the defect curvature of field, that means curvature produced in the image, is opposite to the curvature of the convex lens. Thus, in case of convex lens, the curvature defect is two types, for the real image and for virtual image. Now coming to the concave lens. Concave lens always forms virtual images only because it is a diverging lens. Here in this case, the image is curved and the object is flattened. Flat object, curved image. This is the defect. In this case also, the curved surface of the image is opposite to the curved surface of the object. That is, for virtual image, the curve forms will be the opposite to the curve of the lens, whether it may be a convex lens or a concave lens. Now coming to another explanation of curvature of field, that means the defect of the curvature of field in case of microscopes and telescopes. Now a simple lens forms the image of an extended flattened object such as a specimen on the microscope slide onto a spherical surface resembling a curved bowl. The curvature of this surface is the reciprocal of the lens radius and is referred to as Pedgeval curvature of the lens. The curvature of the surface is reciprocal to the lens radius. That means as lens radius increases, the defect curvature of the surface decreases. As the radius increases, the defect decreases. Now, here this is the lens. This is the object, flat object, and this is the curvature. This portion is said to be the Pedgeval surface. Now, the image can be focused over a large number of focal planes positioned between A and B. Here, the optic center is A, and the extreme vertex point is B. Now, different the image can be focused over a large number of focal planes positioned between A and B to produce either a sharp focus on the edges or in the central image. So, this the image corresponding to the central portion A is here, and the image corresponding to the vertex is here. So, from A to B, there are large number of zones. That means the image formed becomes defected. When the specimen is viewed in the eyepiece, it can be also called as oculars of a microscope. It either appears sharp and crisp in the center or on the edges of the field of view, but not the both. So you can view the image sharp at the center or at the edges, but not both at a time. So this is a defect. This occurs because the greater distance of off-axis points from the lens center results in closer off-axis image. So greater distance of off-axis points. Off-axis means which are distant from the axis of the lens. Normally, this curvature of field is not a serious problem when the microscopist is routinely scanning the samples to observe their various features. It is a simple matter to use the fine focus knob to correct small deficiencies in specimen focus. So, normally this curvature of field defect is neglected because this can be simply rectified by fine focus knob. But photomicrography application, the field curvature can be a serious problem, especially when the portion of photograph is out of focus. So, with a simple lens, this is the specimen and this is the image of the specimen. Hence, you are getting the blurred image here due to the curvature of field aberration. So, this is a defect and this has to be rectified. Now, the curvature of field can be explained by using several photographs representing a variety of illumination techniques. So, by taking large number of photographs, one can explain about curvature of field. When the image position slider is moved to the far left, the central portion of the image is in focus with outer portions of the image become very blurred. It is not possible to distinguish any minor structural details present at the edges of the view field. That means in this case, the central portion is somewhat clear and the outer portions are blurred. Now, when the slider is moved to the far right, the opposite effect occurs, with the central portion of the image becoming out of focus and the edges coming into sharp focus. The middle portion, that means when you move the slider to far left, the central portion is sharp. When you move the slider far right, the outer portion is in focus. But in these two cases, the better option is to focus at the center. The middle portion of the slider range represents the best compromise between the center and edge focus. That means the curvature of the field can be somewhat minimized in case of the microscopes in viewing the slides. The central portion has to be focused. Now, the minimization methods of curvature of field defect. So if you use number of lenses, that means 1, 2, 3, 4, etc. n number of lens, then the radius of curvature, here the defect is curvature and hence we are using the relation for curvature. The radius of curvature 1 by r equal to sigma 1 by mu n fn. Here mu is refractive index of nth lens and fn is focal length of nth lens. So 1 by mu1 f1 plus 1 by mu2 f2 plus 1 by mu3 f3 and so on plus 1 by mu n fn. That is the meaning of this equation. Here the curvature is the defect. That means defect in the forming the flat object. The image of flat object must be flat. So for flat image r equal to, that means radius of curvature is infinity. That means in order to rectify the curvature of field defect, this condition must be satisfied, which means 1 by r equal to sigma 1 by f1, that is equal to 1 by infinity, which is equal to 0. So for two lenses placed in air means mu1 equal to mu2 equal to 1. So you will get 1 by mu1 f1 plus 1 by mu2 f2 equal to 0, which implies mu1 f1 plus mu2 f2 equal to 0. For the two lenses placed in air, mu1 equal to mu2 equal to 1, which means f1 plus f2 equal to 0. So this is called Pecqual condition. Pecqual's condition. Mu1 f1 plus mu2 f2 equal to 0 is said to be Pecqual's condition for two lenses in case of elimination of curvature of field. This condition holds good either the lenses are in contact or separated by a distance. So, the condition for minimizing the curvature of field defect is said to be Pecqual's condition, and it is nothing but mu1 f1 plus mu2 f2 equal to 0. Coming to second minimization method, this is the minimization method for all monochromatic aberrations. So, in case of thin lenses, curvature can be eliminated by placing a stop in suitable position in front of the lens. Here we are using stop like this. That means it cuts marginal rays and allows only paractal rays. That means the defect is somewhat minimized, and here we are focusing the central portion of the lens. Hence, you can get somewhat better image for the central portion of the object. Now the third is curvature of field may be eliminated by using meniscus shaped lenses. This is the meniscus shaped lens. So by using lens doublet group, here there are two lenses, meniscus shaped lens, and here is a normal lens and lens doublet group. So any number of lenses can be used depending upon our requirement. By using meniscus shaped lens, we can minimize the defect curvature of field in forming the image by the lens. So the curvature of field can be eliminated by using stops, by using meniscus shaped lenses.